Go.
So as we just demonstrated, the cart moved across the floor at a constant velocity of 2 meters per second in the left direction. Now for free body diagrams, it starts with a box. This box represents the cart. Now the cart acting downward upon it was the force of gravity. This is equal to the mass times gravity. The force acting up on it is considered the normal force. Now because it's at a constant velocity of 2 meters per second, acceleration is equal to 0. This means that the net force would also be 0 because mass times acceleration of 0 would give you a 0 net force. This means that the force of gravity is equivalent to the normal force. Now, if the cart was 10 kilograms, then when I do the force of gravity, I plug in gravity is negative 9.8 meters per second squared because gravity pulls the object down. So this means that the force of gravity would be negative 98 newtons. Kilogram meter over second squared is equivalent to newtons. This means that the force of gravity is negative 98 newtons acting upon the cart, which would mean that the normal force, because it is going upward, would be positive 98 newtons. This is the free body diagram for the cart.
Natalie pushes the cart across what we're going to assume is a frictionless surface. She pushes it with an acceleration of 3 meters per second squared. Now you can find the forces acting upon the cart in a free body diagram.
Excuse me, Mrs. Martini, you forgot the second squared for acceleration.
Thank you, Natalie. This is why you're such a great student. The force of gravity remains the same, and the normal force remains the same, because the force of gravity is a constant value that is always the same. Since the cart is being pushed this way at 3 meters per second, we have to find this force. So since we are assuming a frictionless surface, F net is going to be the only horizontal force acting upon the cart. F net is equal to Ma. Since the mass is 10 kilograms and the acceleration is 3 meters per second squared, we're given a total force of 30 newtons. This is because when you multiply these two, your total unit turns out to be kilogram meters per second squared, which is equal to 1 newton. So the value we determined for the net force is only the net force of the horizontal cart, while the net force for these, the vertical, is going to be 0 because these two cancel out, and the net force horizontally is going to be 30.